Hello. In today's video, we are going to be covering IXL Assignment Understanding Negative Exponents. Now, before we actually switch on over to IXL itself, let's go ahead and review our properties of exponents. All right, here we have our nice little diagram that shows us all the different properties of exponents. However, don't get overwhelmed because in this video, we're not doing all of them. We're just focusing on one, so that way we can learn a few at a time. So let's go ahead and zoom in on our focus for today, negative exponents. The reason we're starting here, and this is a great beginning place, is because when you work with exponents and you apply these properties, your final answer cannot contain negative exponents. Therefore, if you have an answer with a negative exponent, we need to simplify it so that way our final form only contains positive exponents. All right, here we have our generic rule. So with these generic rules, this generic property, we use all variables because then it can apply to anything. So if we have a base with a negative exponent, in order for that negative exponent to be positive, it's kind of like we're turning that frown upside down. So we need to move the negative exponent to the other side of the fraction, and that will change its sign. So moving from one side of the fraction bar to the other changes its sign, and in this case, it makes it positive. So right now, our negative exponent is in the numerator, so when it's moved to the denominator, it becomes positive. The same is true in this second example. If the reverse happens, if we're given a problem and the negative exponent's in the denominator, when we move it up to the numerator, it changes its sign and becomes positive. All right, let's do a couple examples with numbers because maybe that will help make it click. Because I know for me, that along with seeing multiple examples is one way I learn. All right, if you are given the problem 3 to the negative 2, I see that right away and I'm like, oh boy, negative exponent, can't have that, it's unhappy. Well, remember, in order to change an exponent sign, you move it to the other side of the fraction. Wait a minute, I don't see a fraction here. So how in the world am I supposed to move it to the other side of the fraction when there is no fraction? Guess what? We can rewrite it as a fraction. I know you may be thinking, oh goodness, Mrs. Ailstock, I don't like fractions. They're not my thing. Don't worry. It'll be okay. We'll get through this together because we're not really doing any operations for fractions. In this case, fractions are our friend. We need them in order to make our negative exponents positive. So remember, from when you did work a lot with fractions, that you can rewrite any whole number as a fraction by putting it over 1. So we can rewrite 3 to the negative 2 power as a fraction. So 3 to the negative 2 power over 1. The reason you can make something a fraction or rewrite it as a fraction by putting it over 1 is because fractions are a way to show division. And if you divide something by 1, does it change its value at all? No. Let's think of another example. If we have 5 divided by 1, that's 5. If you have 100 divided by 1, that's 100. So 3 to the negative 2 power divided by 1 is 3 to the negative 2. So these are equal, they're equivalent. I just need it to be rewritten as a fraction so I can apply this property and make my negative exponent positive. So get off my little soapbox there. There's the y. Now let's get into it. Okay. We have a negative exponent, but in order for him to be positive, we need to move it to the other side of the fraction. We got to turn that frown upside down. So right now we're in the numerator, but to change its sign and make it positive, my 3 to the negative 2, I should have circled the whole thing. because it makes it look like we're only moving the exponent. And no, we have to move the base and the exponent. They're attached and cannot be separated. All right, it went from the numerator and it was negative, and looky here, it's now in the denominator and it's positive. So mission accomplished. And sometimes, and I think most of the time on this IXL assignment, this is how it wants you to leave your answers. Just leave it in exponential form. But let's go ahead, just for funsies, and take it one step further and simplify completely. So to simplify completely, we need to simplify that 3 squared. Remember, 3 squared means 3 times itself 2 times, and 3 times 3 is 9. So our simplified answer is the fraction 1/9. Okay, let's go ahead and do one more example before hopping on to IXL. Let's do one that looks like our bottom example here. All right, we have the problem. We have the fraction 1/7 to the -2 power. But uh-oh, I see a negative exponent again, and I know I can't have that. My simplified answer needs to be positives. So we need to turn that frown upside down. We need to make that negative exponent positive. Well, I actually get to save a step because it's already written as a fraction. So I don't need to rewrite it as a fraction. I can just get going. And if the negative exponent is in the denominator, when we switch sides, so when we move up to the numerator, it will become positive. 7 over negative, so 7 to the -2 was in the denominator. Once it moved up to the numerator, it changed its sign and became positive. Yay! Do we need to leave this as a fraction? No, because we talked about just a minute ago how when you divide something by 1, it doesn't change it at all. And I don't need it to be a fraction anymore. So I can write the equivalent form, 7 squared. And again, on 99%, possibly even 100% of your IXL questions, it's going to ask you to leave your answer in exponent form. You'd be done, 7 squared. But just for fun again, let's simplify it completely. 7 squared would be 7 times itself 2 times. So 7 times 7 is 49. All right, let's get to IXL. Let's work some of these fun problems out here. Oops. Okay, there we go. On the left here, we have the IXL assignment, understanding negative exponents. And on the right, I took a nice little snippet of the examples we just did together so you can have that as reference. We want to know which is equal to 8 to the -7 power. All right. My first thing is I see I have a negative exponent. So if I want to know which one is equal, there's probably going to be a positive version because these technically are equivalent because I didn't really change the value at all. I just rewrote it so it became positive. Let's go ahead and rewrite this exponent as a positive exponent. I'm going to bring my work down here so I have room, 8 to the -7 power. Now, to make a negative exponent positive, we need to change what side of the fraction it's on. But do you see a fraction right now? No. So let's rewrite it as a fraction. How do we rewrite something as a fraction again? Put it over 1. Now it's rewritten as a fraction, which means we can move the 8 to the -7. It's currently in the numerator. We can switch sides, move it to the denominator, and it will change its sign, make it positive, make it happy. So this negative right here is what's causing our move. Now, when I bring it down to the denominator, I already have a 1 down there. But if you multiply something by 1, does it change its value? No, because 1 times 8 to this negative 7th would still be 8 to the negative 7th. All right, is a negative in the numerator. I switch sides. It's now a positive. But can I leave a numerator blank? No, that I can't do because then it's an empty fraction. So a 1 will go up top. And there we go. Now let's see if this matches any of our answer choices. Does not match that one. Nope. Ah, here's our winner. Very good. Perfect. All right, let's try another one of these. Which is equal to 1 over 5/9? Well, this time, I don't see a negative exponent in my initial problem, but I see quite a few negatives down below. So let's take our original problem, and I know that I said you don't want your final answer to be a negative exponent, and that's true when you're evaluating. But for this IXL assignment, since it's just getting you to practice changing back and forth, and also it wants to know which one of these answer choices is equivalent, we're gonna make something negative. All right, our original is 1 over 5/9. But I need to change its sign. To change the sign of an exponent, you move it to the other side of the fraction. Is my problem already given to me as a fraction? It is. I love it when that happens. It saves a step of work. It's already as a fraction, and currently my exponent is right here in the denominator. So if I want to change its sign and make it negative, it's going to go from the denominator to the numerator. That's right. So we want to move it up. That's a terrible arrow, but that's okay. Looks more like a 5. Eesh. Let's fix that. I'm too OCD to just let it go. There we go. That looks better. All right. Once again, like before, when we move it up there to join the 1, when you multiply something by 1, it stays the same. So 5 to the 9, but since I changed signs, it's no longer a positive 9. It is now a negative. All right. This is great. But let's simplify it. Do I need, like if I have something over 1, yes, that's fractional form, but do I need to leave it that way? No, I don't. We can just erase that. We don't need it to be a fraction anymore because there's nothing else other than 1 in the denominator. So 5 to the negative 9 is equivalent, is equal. And that happens to be our very first answer choice. Awesome. All right. Let's go ahead and jump up a level and do another type of problem before we end. Ah, beautiful. Write the expression as a fraction with a positive exponent. Do not evaluate the expression. If we break down these directions, I'm going to focus it on this last sentence. Do not evaluate. If we look to the right at these examples I did earlier, my final answer here was me evaluating, because when you evaluate, if we break down that word, see how the word value is in it? We find a value. We find a final number answer. It does not want me to do that, which means my final answer is going to be in exponent form. So it'll look like one of these two. And that's important to distinct because I don't want you guys to use your calculator and evaluate this and get it wrong. So we're going to make sure that we rewrite it with a positive exponent, and then we'll leave it in exponential form. Okay, 4 to the negative 23rd power. I have a negative exponent. I need to make it positive. So first thing I look to see is it already written as a fraction? It is not. So that means my next step is to rewrite it as a fraction. And how do you rewrite something as a fraction? Put it over 1. Once it's written as a fraction, how do we turn that frown upside down? How do we make a negative exponent positive? Move it to the other side of the fraction. We are currently in the numerator, so we're going to bring it down to the denominator, which will change its sign and make it positive. But we can't leave the numerator blank, so we have a nice 1 up top. And then 4 and negative 23rds moves to the bottom. When it moves to the bottom, it becomes 4 and a positive 23rd. Awesome. Now, I got a little panicked there because I'm like, oh no, I don't see the ability to make an exponent. But it appeared once I clicked in the answer box. So here we have 2 different format tools. This one gives you just a simple exponent. The second one allows you to make a fraction, which we actually need both. So first, we are going to press the button that gives us a fraction. Our numerator is 1. And then I'm going to click down in the denominator and use the other button, because now in the denominator, I need the ability to write an exponent. So 4 is our base, raised to the power of 23. We should be good to go. We will do one final example, and then we will close out. So write the expression as a whole number with the negative exponent. Do not evaluate the expression. Okay, so similar examples to last time where we're not going to evaluate, only how are we rewriting it? Yeah, it wants us to rewrite it as a negative. And remember, for this IXL, it just wants you to be able to rewrite them both ways. That's why it's having you take something that's a positive and rewrite it to be a negative. But typically, you want your answers to be positive. But that's okay. This is just practice to make sure you can convert between the 2 forms. Our original problem is 1 and 78 to the 15th power. First question, is it already written as a fraction? Yes, it is. And when it's written as a fraction, we don't have to do that second step because it's already rewritten like that for us. Now we want to change the sign of our exponent. It's already a positive. We want to make it a negative. The same thing still applies. When we change sides of the fraction, it changes the sign of our exponent. So if it's in the denominator, it's positive. That means when I move it up to the numerator, it will become negative. Let's do that. Move it on up. When I multiply something by 1, it doesn't change any. We can bring it up, no problem. And it flipped sides, it becomes a negative. All right, final question. Do I need to leave it as a fraction, or can I simplify it a little bit? Yeah, I can simplify it some, because when you divide something by 1, it doesn't change any, which means we don't really need to leave it as a fraction. We can just simply write it 78 to the negative 15th power. Once again, our little buttons are here for us to get the right form in. 78 is our base, negative 15. Oops. Watch when you type, you don't want to have it right on your paper and accidentally have a typo. Oof, that'd be so annoying for your smart score to drop. So don't ever rush. Do like I did. Take a moment to make sure that you typed it in correctly. And we're good to go. All right, guys, I hope this video was helpful and allows you to understand a little bit better how to switch back and forth between negative and positive exponents. As always, if you have any questions, just send an email to your specific teacher or come to our help sessions. We'll be happy to assist. Bye.